Okay, we're working on chapter 7.4, special right triangles. Uh, this may be a little bit different than what you're used to, but in any case, this should be a good video to watch, and you don't have to watch the whole thing, but it's a good video to watch in order to get some shortcuts in order to make your life easier when it comes to dealing with the right triangles. So the first we're going to look at is an isosceles right triangle, as you can see right here. This is an isosceles because it has two congruent sides that are 4 and 4, right? Okay, now, if I go ahead and set this up in the Pythagorean theorem and I want to find my c here, setting this up in Pythagorean theorem, I'm going to have 4 squared plus 4 squared is equal to c squared. So if I work that out, I'm going to have 16 plus 16 is equal to c squared. 16 plus 16 is 32 is equal to c squared. If I want to solve for c, I need to take the square root of 32 or the square root of c. And then what you're going to end up with, if I simplify this radical, and just kind of a review of that, because I know some of you guys struggled with this on the quiz, I'm going to have 16 times 2, which equals c squared. I'm sorry, c. If I continue to simplify the radical, I take out what I can square root out of there. So square root of 16 is 4, so that comes out. Times the square root of 2 equals c. Okay? So, on this one, it would be a is equal to 4, b is equal to 4, c is equal to 4 square roots of 2. Okay, I want to do something a little bit different than the other video that you might watch if you watch Miss Wilson's video still. I want to show you another example before we get into the details of the shortcut. Okay, so what if I change 4 to, we'll just go with 6. And this is 6. And I'm still looking for c. So let's set this up. 6 squared plus 6 squared is equal to c squared. 6 plus 6, or 6 squared is 36, plus 36 is equal to c squared. 36 and 36 is 72 is equal to c squared. And now I want the square root of 72 to get c. So the square root of 72 is 6 square roots of 2. And again, actually, let me go back. I want to show you that breakdown. Again, you have square root of 36 times 2 is equal to excuse me. Square root of 36 is 6. Square roots of 2, right? Because square root of 36, the 6 comes out, equals c. So on this triangle, with these dimensions, you have a is equal to 6, b is equal to 6, c is equal to 6 square roots of 2. So you should be able to start seeing a pattern now, because that's where our shortcut is going to come into play, is by using this pattern. So I'm going to go ahead and erase this, and I'm going to go ahead and set it up generically. One more time. Let's do x, x, and this is still c, right? Okay? So last example, I'm going to have x squared plus x squared is equal to c squared. Well, x squared plus x squared is 2x squared is equal to c squared. If I square root it, if I divide both sides by 2, sorry, I don't want to divide by 2, my mistake. I forgot, I'm getting c by itself, not x. Okay, so if I want c by itself, I need to square root both sides. Well, the x squared square rooted is just going to come out as x. Square roots of 2 is equal to c. And so again, for our last one, we have a is equal to x, b is equal to x, and c is equal to x square root of 2. So now hopefully you can see the shortcut when you do this. So if I quickly said to you, the side lengths are, I'm going to erase these now that we're done with these. If I quickly said to you, I said, hey, you know what? The side lengths are, of an isosceles right triangle, the side lengths are 10.4 and 10.4. What is C? You should easily be able to say, if this is 10.4 and this is 10.4, C must be 10.4 times the square root of 2. And obviously that's a weird number, but that's part of the trick, right? If I said something even more generic and I said something along the lines of your side lengths of an isosceles right triangle, let's say I said isosceles right triangle, your side lengths were, let's say Z and Z, what would C be? C would be equal to Z square root of 2. You can also use this for other things as well. If I'm still dealing with an isosceles right triangle, and I gave you the side length, and if I said the hypotenuse, I said, okay, hey, C is equal to 10 square roots of 2. What does A equal? Okay, so I had to pause that for just a second, but just to kind of go back, if you're given the hypotenuse of 10 square roots of 2, you can easily find A and B. A is simply going to be this first number right here, this 10, and B is going to be 10, obviously because they're isosceles, right? Isosceles, so they're going to be congruent. You can use the Pythagorean theorem for all of this if you wanted to. If I was to set this up in Pythagorean theorem form, you could have x squared plus, x squared, because they're, again, you have to set it up like this because they're congruent, is equal to 10 square roots of 2 squared. Okay, so then you end up with x squared, 2x squared is equal to 100 times 2. So 2x squared is equal to 200. Divide both sides by 2. And you get x squared is equal to 100. Square root 100, you have x is equal to 10. And since x is 10 in this particular Pythagorean theorem setup, we know A and B are both 10 as well. So that can work in both directions if you need to do that quickly. And again, this is just a shortcut method. Okay, what happens if I have a number like 5 square roots of 2 and 5 square roots of 2? Well, based on what we know that in order to get the shortcut, we should have 5 square roots of 2 square roots of 2, right? Because earlier when we had 6 and 6, it would have been 6 square roots of 2. So what is 5 square roots of 2 times the square root of 2? Well, you just multiply the outside numbers of your radicals, which is 5 and 1, so then you have 5, times, then you take your radical numbers, and you multiply the underneath. So then it becomes square root of 4. Square root of 4 is 2, so you have 5 times 2, which is 10. Okay, so Let's look at another one real quick. And let's look at this in the form of the Pythagorean theorem. So let's do, instead of 5 square roots of 2, let's change it to 6 square roots of 2 and see what happens. I'm going to leave the work over here for this one so that we can see and compare. So let's do 6 square roots of 2 and 6 square roots of 2, but this time we're going to use the Pythagorean theorem. So 6 square roots of 2 squared plus 6 square roots of 2 squared is equal to c squared. Well, 6 square roots of 2 squared, if again, we want to distribute that exponent to both, you end up with 36 times 2 plus 36 times 2 equals c squared. 36 times 2 is 72. So you have 72 plus 72 is equal to c squared. Well, 72 times 2 is 144 equals c squared. So you square root that and square root that, and you end up with 12 is equal to c. So what kind of pattern are you noticing? Yeah, it's simply, in this case, 6 times 2 is 12. Here, on the 5 side, it was 5 times 2 is 10. So there's another shortcut. And again, all of these shortcuts deal only with isosceles. It's very, very important that you understand it's only isosceles triangles. That's it. Okay? Do not use this for every triangle. It will not work. All right, so just a quick recap of that one. You know that the hypotenuse, if I can spell right, is equal to the leg times the square root of 2. Okay? And that's pretty much all you need to know for that particular shortcut. And then again, I showed you the other shortcut back here, you know, with multiplying the leg. If you have that leg, you just multiply the number underneath, okay, and so on and so forth, okay? And again, if this doesn't work for you, that's fine. Use your... Okay, now let's take a look at an example that you saw that was kind of like on your quiz. We're looking at a triangle, and it's an isosceles triangle, but then you have an altitude that comes down and splits this bottom part into 2 congruent parts. So if I was trying to figure out this value here, one of my leg values, I would set this up as x squared plus 4 squared is equal to 8 squared. Make sure you put this in the right order. You know, A, B, C, something like that. Okay, make sure it's in the right order. And then if I work this out, I'm going to end up with x squared plus 16 is equal to 64. If I continue to work this out, I have x squared is equal to 64 minus 16. Comes out to be not what I have there. Let me get rid of that. 48. And then the square root of 48 is going to be our x value. So the square root of 48 is not a perfect square, but what numbers could I turn this into? Yeah, the square root of 16 times 3, that's my perfect square, and then I end up with x is equal to the 4 square roots of 3. Okay? Let's change that. Let's change this to, instead of 8, we'll change this to 6. This is 6 and this is 6. So if I set up my new problem using 6, I now have x squared plus 6 squared is equal to, not 6 squared, 3 squared is equal to 6 squared. So x squared plus 9 is equal to 36. X squared is equal to 27. I have to square root that. So x is equal to, and this is the same thing as saying 9 times 3, so 3 square roots of 3. Again, where do we see this 3 and where do we see this 4 before? Hopefully you're figuring out the pattern. What you see here is you have one leg, in this particular case is 3. This is 3 square roots of 3, and of course you already had the 6 there. The other one was 4 square roots of 3, and double that first one, which was 8. Okay? This one is called a 30, 60, 90 triangle. Okay? 30, 60, 90. And the reason that is because if this is isosceles, if the big triangle is isosceles, and this is 6, that means this angle and this is 6, and this angle are congruent. And so essentially what happens is all three of these are congruent, and that means they're all 60, right? Well, if these are all 60 degrees, you have your altitude, makes this 30 degrees. This is obviously 60 degrees, and obviously 90 degrees. That's where you get your 30, 60, 90. So when you set up the shortcut, if you will, what you're going to have is for the 30, 60, 90, you're going to have A is your across from your 30 degrees, A square roots of 3. Let me write this out a little bit better so it's more clear. So you have 30, 60, 90 triangle. So across from your 30 degrees you have A, across from your 60 degrees you have A square roots of 3, and across from your 90 degrees you have 2 times the A value. So if we go back to our original one, okay, we started with 8 and 4, right? So if you take that 4 as A, 2 times 4 is 8, and then I had 4 square roots of 3. And then we did, the A value was 3, then we had 3 square roots of 3, and then we had 6. That's the last example we did right here. So what if I had an A value of 5? This is going to be 5 square roots of 3, and this is going to be 2 times 5, which is 10. Same thing if I had 7. I'd have 7 square roots of 3, and then 14. Okay? What about here? What if I had 4 square roots of 3? What would 60 be? It would be 4 square roots of 3 times square root of 3, right? Well, square root of 3 times the square root of 3 is like saying the square root of 3 squared. So then you end up with 4 times 3, and then this becomes 12. So you have 4 square roots of 3, 12, and then 2 times 4 square roots of 3, and all you have to do is multiply the outside number, is 8 square roots of 3. So you have 4 square roots of 3 is my A value, then you have 12, and then you have 8 square roots of 3. Okay, what if I'm given this? What if under my 30, 60 column, 30, 60, 90 column, under 60 I'm given 9? Well, I know that this is supposed to be equal A square roots of 3. This is A, and this is 2A. So how do I figure this out? Well, to find A, I've got to take 9 and divide it by the square root of 3. So A is equal to 9 divided by the square root of 3. Well, you could simply plug that into your calculator, but if it comes out with a radical number, you're going to have it in the simplest radical form. So the way we do this is what we call rationalizing the denominator. When we rationalize the denominator, we multiply by the denominator that's in a radical form, so square root of 3 over the square root of 3, because this is essentially 1, right? And we're not changing the identity of this number, so it's 1. Well, what happens is I end up with 9 square roots of 3 over when you multiply square root times a square root, it's just going to cancel out. It's got to be the same, first of all, same number under the radical. It's going to cancel out your radical signs and just give you 3. So square root of 3 times the square root of 3 is going to equal 3. And if you don't trust me, put that in your calculator, you'll see. So then you end up with 9 square roots of 3 over 3. Can I simplify this more? Yeah, 9 divided by 3 is 3 square roots of 3. So now we have 3 square roots of 3, 9, okay, so 3 square roots of 3 is our A value, 9 is our B value, and then 2 times 3 square roots of 3, and 2 times 3 is 6 square roots of 3. So that will be our number. This part might be a little tricky because you have to rationalize the denominator, but I can help you with that. No problem. If you have any questions, this is pretty much the gist of it. Hopefully it's significantly easier than yesterday, but if you have any questions, please write them down. Come see me in tutoring, and we'll talk about this more in class tomorrow. Other than that, you guys have a great evening, and I will see you tomorrow.